A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you are listening to an AI-generated audiobook. The narrator is gliding through a beautiful English description of a sunset, and then the character quotes a line of Hebrew poetry. Suddenly, the voice turns into a complete train wreck, mispronouncing every syllable because it can't find the vowels. Or maybe it's a Hindi podcast where the host drops a technical term like serverless architecture, and the AI tries to pronounce it using phonetic rules meant for Sanskrit. This gap between English-centric perfection and the messy, beautiful reality of global linguistics is exactly what we are digging into today.
It is a massive technical hurdle. We often talk about AI as this universal translator, but when you get down to the actual synthesis turning text into a human-sounding voice, the universal part starts to crumble. Today's prompt from Daniel is about the current state of multilingual text-to-speech, or TTS, and the specific hurdles that keep most of the world's languages in the uncanny valley, while English gets all the polish.
By the way, if we sound particularly sharp today, it might be because Google Gemini 1.5 Flash is writing our script. Hopefully, it knows how to pronounce its own name in multiple languages. Now, Herman Poppleberry, let's get into the weeds. When we say multilingual TTS, are we talking about one giant model that knows everything, or a bunch of small models duct taped together?
That is the big architectural debate right now. Historically, it was the digital sandwich approach. You'd have a language identification model, then a text normalizer specific to that language, then a phoneme converter, and finally a vocoder to make the sound. But in 2026, we're seeing a shift toward unified architectures. Think of things like Meta's AnySpeech or the latest iterations of OpenAI's voice engine. They use a shared encoder that tries to understand the essence of speech across all languages, then uses language-specific embeddings to steer the output.
A shared encoder sounds efficient, but I imagine it's like a polyglot who speaks 10 languages but has a slight accent in all of them. Is there a quality trade-off when you try to cram the entire world's phonetics into one model?
There absolutely is. This is often called language interference or capacity dilution. Imagine a model's brain as a suitcase. If you only pack for a trip to London, you have plenty of room for heavy coats and specific gear. But if you're trying to pack for London, the Sahara, and the Antarctic all at once, you're going to leave some things out. If a model is spinning its parameters learning the tonal nuances of Mandarin and the click sounds of Xhosa, it might actually lose some of the fine-grained prosody, the rhythm and intonation that makes English sound natural. It's a balancing act. But before we get to the one model to rule them all, Dream, we have to talk about why some languages are just fundamentally harder to turn into speech than others.
Right, and Daniel pointed us toward Hebrew as a prime example of this. I've seen written Hebrew. It looks like a beautiful series of characters, but to the uninitiated, it's missing half the information.
It's missing the vowels. This is the Nakud problem. In standard modern Hebrew text, like what you'd see in a newspaper or a text message, the vowels, or Nakud, are omitted. The reader just knows, the word based on context. For a TTS model, this is a nightmare. The word for book and the word for border might be spelled identically in consonants, Samik P. Resh. Without a pre-processing step to diacritize the text, meaning adding those little dots and dashes that represent vowels, the TTS engine is literally guessing.
So it's not just a voice model, it's a detective agency. You need a separate AI model just to sit in front of the voice engine and say, okay, based on the 3 words before this, he's definitely talking about a book, not a border.
Spot on. And that pre-processing model, the diacritizer usually has to be a sophisticated sequence-to-sequence transformer of its own. It's analyzing the syntactic structure of the entire sentence to decide if a verb is past tense or present tense, which changes the pronunciation. If that model slips up, even by a tiny bit, the voice engine is doomed. It's not a voice error at that point, it's a reading error. This is also a huge issue in Arabic, where short vowels are also frequently omitted. You have harakat, or diacritics, that change the meaning and the pronunciation entirely. If you're building a multilingual TTS and you don't have a top-tier Arabic or Hebrew text normalization layer, your high-end neural vocoder is just going to produce very high-quality gibberish.
I love the idea of high-quality gibberish. It sounds confident, but it's totally wrong. It's like a politician. But wait, how does this work when you're reading something like a medical journal or a legal document? Surely the stakes for a reading error are way higher there than in a casual podcast.
Oh, the stakes are massive. Imagine a TTS system reading a prescription instruction in Arabic or Hebrew and getting the vowel wrong on a dosage-related word. That's why in high-stakes environments you often see constrained TTS, where the model is forced to check against a dictionary of known valid pronunciations. But even then, the AI has to understand the grammar. In Arabic, the word kataba means he wrote, but kutiba means it was written. The consonants are exactly the same. If the AI doesn't understand the passive voice, it says the wrong word.
It's like the AI needs a PhD in linguistics before it's allowed to speak. But what about when we mix languages? Daniel mentioned code switching. I do this all the time, using a bit of French or some tech slang in the middle of a sentence. How does a model handle that without sounding like it's having a stroke?
Code switching is the final boss of multilingual TTS. There are three ways models handle it. The old way was hard switching, where the system detects a language change and swaps the entire model mid-sentence. The problem? There's usually a tiny audible click or a change in the room tone of the voice because the two models weren't trained on the same microphone or in the same studio. It sounds like two different people are talking.
That sounds terrifying. Like a poltergeist in my GPS. 1 second it's a polite British lady, and the next second a gravelly German man is yelling, "Turnen Sie links."
It breaks the immersion completely. The second way is phoneme mapping. You take the English word, say, computer, and you map its English sounds to the closest equivalent sounds in the primary language, like Hindi. But then it sounds like a Hindi speaker with a very thick accent saying computer. It doesn't sound like a bilingual person, it sounds like a monolingual person struggling with a foreign word. The third, and most modern way, is cross-lingual voice cloning. This is where the model learns the identity of a voice. Your voice, my voice, independent of the language. It can then apply that identity to the phonemes of any language. So, it's corn speaking English and then corn speaking Japanese, with the same vocal fry and the same cheeky tone.
I'm not sure the world is ready for corn in Japanese, Herman. But that sounds like a massive data problem. If you want to train a model to do that, you need recordings of people who are actually bilingual, right? You can't just feed it a bunch of separate monolingual datasets and hope it figures out how to bridge the gap.
That's been the traditional view, that you need parallel data where the same person speaks multiple languages. But 2025 and 2026 have seen a breakthrough in unpaired learning. Researchers are finding that if you have enough data in language A and enough data in language B, the model can learn an abstract representation of speech that works for both. It's like learning the concept of melody separately from the concept of lyrics. However, the data gap is still staggering. A 2025 report from Mozilla Common Voice showed that roughly 80% of all available high-quality speech data for training is concentrated in just 10 languages.
10 languages? Out of the thousands spoken on Earth? That's a digital divide you could fit a galaxy through. I'm guessing English is number one, but who else is in that top tier of TTS support?
English, Spanish, Mandarin, French, German, Japanese, Portuguese, Russian, Italian, and Korean. If you speak one of those, you're living in a golden age of TTS. The voices are indistinguishable from humans. They have emotion, they breathe, they can whisper, they can even handle sarcasm. But if you move even slightly outside that circle to something like Yoruba, Amharic, or even some of the regional dialects of India like Marathi or Telugu, the quality drops off a cliff. You go from a Hollywood voice actor to a 1980s speak and spell in about 5 miles.
It's the great data exhaustion we've talked about before. If the AI hasn't heard it, it can't say it. But it's not just about the amount of data, right? It's about the script. We talked about Hebrew and Arabic, but what about something like Chinese or Japanese? Those aren't even phonetic scripts in the way we think of them.
Oh, the East Asian logographic. Scripts are a whole different level of complexity. In Chinese, you have the character to phoneme mapping. One character can have multiple pronunciations. These are called polyphones. The word for music and the word for pleasure in Chinese use the same character, but are pronounced differently, yuas for music and ler for pleasure. So again, you need a heavy-duty front-end model to do the disambiguation before the voice engine even starts.
And Japanese is like the advanced level version of that, right? Since they mix three different writing systems in a single sentence?
It's a mess. You have kanji, which are Chinese characters, hiragana, which is phonetic, and katakana, which is used for foreign loanwords. A Japanese TTS engine has to segment the sentence correctly. If it breaks the characters at the wrong spot, it's like reading a sentence in English without any spaces. Seppen is mightier than Theesward. Depending on where you put the breaks, that sentence goes in two very different directions.
I see what you did there, Herman. Very subtle. But let's look at the loanword problem. When a Japanese speaker says McDonald's, they say Makudonarudo. Does the AI know to use the Japanese phonetic version, or does it try to say it like an American, which might actually sound wrong to a Japanese listener?
That's a brilliant point about localization versus globalization. A truly great multilingual model needs to know its audience. If the AI is reading a Japanese news report, it should probably use the Japanese pronunciation of foreign brands. But if it's a language learning app, it might need to toggle between the two. This is where metadata comes in, telling the model not just what to say, but who it is supposed to be when it says it.
I see. So, if I'm building an app for the global market, do I go with one of these giant multilingual models, or do I try to hunt down specific models for each region? What's the prosumer move here?
This is where the trade-offs get really interesting. If you use a giant multilingual model like what SiliconFlow or Cam.ai are offering in 2026, you get incredible zero-shot capabilities. You can give it a 3-second clip of a voice and it can speak 50 languages in that voice. That's great for scale. But, and this is a big but, a 2025 study showed that fine-tuning a small language-specific model on just 10 hours of high-quality data often outperforms a massive multilingual model trained on 1,000 hours.
Wait, 10 hours beats 1,000? That seems counterintuitive. Is it just because the small model isn't distracted by other languages?
Precisely. Well, I shouldn't say precisely, because there is some benefit to cross-lingual transfer where learning Spanish helps a model learn Italian. But for the last mile of quality, the small model wins. It can dedicate its entire parameter count to the specific phonology, the specific slang, and the specific rhythm of that one language. It's the difference between a Swiss Army knife and a dedicated scalpel. If you're building a reading app specifically for the Israeli market, you'd be crazy not to use a model fine-tuned specifically for Hebrew with a top-tier Nikud inserting front end. The general-purpose global model will always sound a bit like a tourist.
A tourist who's trying very hard but keeps calling the book a border. I get it. So, if I'm a developer and I want to support a low-resource language, something that isn't in that top 10, what's my move? Do I just wait for big tech to eventually get around to it?
No, the open source community is actually leading the charge here. Projects like Koki TTS and Mozilla's work have made it possible for small teams to build their own. If you can gather 10 to 20 hours of clean audio, maybe from local radio or a few hired voice actors, you can take a base multilingual model and fine-tune it. You're basically taking a model that already knows how to speak and giving it a very intensive course in a specific dialect. It's much more effective than trying to train from scratch.
It's like teaching a singer to perform in a language they don't speak. They already know how to control their breath and hit the notes. They just need someone to coach them on the vowels. But let's talk about the non-Latin scripts again. We mentioned Devanagari, the script used for Hindi. What's the specific hurdle there? I know it's phonetic, so it should be easier than Chinese, right?
You'd think so, but Devanagari has inherent vowels. Each consonant is assumed to be followed by an ah sound, unless there's a specific mark, a halant, to suppress it. If the text normalization isn't perfect, the AI will add extra vowels where they don't belong, making it sound like a robot stuttering. Then you have Thai, which doesn't use spaces between words. The AI has to perform lexical segmentation just to figure out where one word ends and the next begins. If it gets that wrong, the prosody, the rise and fall of the voice, is completely ruined. It's like someone reading a sentence with the wrong pauses and emphasis.
That sounds like me before my first cup of coffee. It's fascinating that the voice part is almost the easy part now. We've solved the physics of making a digital larynx sound human. The real battle is in the linguistic intelligence of the front end. It's the text, part of text to speech, that is failing the speech part.
That is a great way to put it. We are moving from signal processing problems to contextual understanding problems, and this is where the political and economic worldview comes in. Most of these models are built by Western companies or large Chinese firms. Their priority is their biggest markets. If you are a speaker of a minor language which might still be spoken by 30 million people, you are often an afterthought. This creates a linguistic dark age for those speakers in the AI era.
And that's a massive missed opportunity. If you're a pro-growth, pro-technology person, you want everyone connected to the digital economy. If you can't interact with an AI in your native tongue, or if the AI sounds like a mocking caricature of your language, you're not going to use it. It's a barrier to entry for millions of entrepreneurs and students. Think about a farmer in rural India trying to use an AI advisor. If that AI speaks in a formal, robotic Hindi that sounds like a 1950s news broadcast, he's going to turn it off.
And it's not just about the words, it's about the vibe. In many cultures, the way you speak to an elder is different from how you speak to a child. In Korean, for example, there are complex levels of honorifics. If a TTS model just translates the words but uses a casual voice tone for a sentence that requires formal honorifics, it's not just a technical error, it's a social faux pas. It makes the AI look incredibly rude.
It's the etiquette layer of AI. We're essentially asking these models to understand human sociology through the lens of audio waveforms. It's a tall order, but I'm curious, is there a fun fact or a weird outlier in the language world that just breaks every model we've tried?
Oh, definitely. Look at Silbo Gomero. It's a whistled language used in the Canary Islands. It's basically Spanish, but instead of vowels and consonants, it's all whistles of varying pitches. Current TTS models, which are built on the idea of a vocal tract with a tongue and teeth, have no idea what to do with that. They try to find formants, the resonant frequencies of the human voice, and there are none. It just looks like noise to the AI.
That is wild. I want to see an AI try to whistle its way through a grocery list. But back to the practical stuff. What about the sovereignty angle you mentioned? Why are countries so worried about outsourcing their voices?
Think about it. If the only way to hear a digital version of your language is through a server owned by a company in another country, you've lost control over your cultural heritage. We're seeing national AI initiatives where countries like Japan or even smaller nations like Iceland are building their own LLMs and TTS models to ensure their cultural nuances aren't erased by a global average. Iceland is a great example. They have a tiny population, but they've been very proactive in working with companies like OpenAI to ensure Icelandic isn't forgotten.
I wonder if we'll see a move toward Edge TTS for this. Instead of sending my text to a massive server in the cloud that runs a one-size-fits-all model, maybe my phone has a small, highly specialized Hebrew module or Hindi module that it swaps in as needed.
We are already seeing that. That's the dual AR architecture Daniel Source mentioned. It stands for Dual Stream Autoregressive. It's a way of having a very fast, efficient base model that handles the general flow and a refiner that adds the language-specific polish. It's perfect for running on local hardware. This is also how we solve the code switching problem without the latency of the cloud. Your phone sees the English word coming, preps the English phonemes, and blends them into the Hindi stream in real time.
So, what's the takeaway for the person listening to this who just wants to know why their Siri or Alexa still sounds a bit off when they ask for a specific song title in another language? Why can it say, play the latest hits perfectly, but it chokes on a French artist's name?
The takeaway is that we are in a transition period. We've moved past the robotic era, and we're entering the multilingual but awkward era. The AI might know the phonetics of the French name, but it doesn't yet have the muscle memory to switch its vocal tract shape fast enough to sound natural. If you're a developer, don't trust the out-of-the-box, multilingual support for anything outside the top 10 languages. Test it. Find the failure points in text normalization, especially for scripts like Hebrew or Arabic, and look into fine-tuning if you want to actually respect the ears of your users.
And if you're a user, maybe have a little sympathy for the AI. It's trying to learn thousands of years of human linguistic quirks, vowel omissions, and weird script mixing all at once. It's a lot for a bunch of silicon chips to handle. Imagine trying to explain to a computer why read and read are spelled the same but sound different, and then doing that for 6,000 other languages.
It is a Herculean task, but the progress is staggering. In 2024, a zero-shot voice clone in a foreign language was a miracle that made headlines. In 2026, it's a standard feature in most APIs. The next step is getting that cultural soul into the voice. The ability to not just say the words, but to understand the why behind the tone. We want an AI that doesn't just speak Italian, but sounds Italian. The gestures, the pauses, the passion.
Well, I hope the cultural soul of this podcast came through, even if our script was written by a Google model. I think we've covered the what, the how, and the why it's broken. It's a reminder that even in the age of silicon, the human element, the way we actually speak to one another, is the hardest thing to replicate.
Just a final thought on the Nikud issue. It's a great reminder that AI often forces us to formalize things we take for granted. We know the vowels because we share a culture and a history. We don't need the dots on the page because the words live in our heads already. And AI doesn't have that shared history unless we explicitly give it the data. It's a reminder that language is more than just code. It's a living, breathing connection between people that requires context to survive.
Deep stuff, Herman. For a donkey, you're surprisingly sentimental. I guess all that time spent in the digital weeds has made you a bit of a romantic about linguistics. All right, let's get out of here before you start reciting Hebrew poetry or whistling in Silbo Gomero.
I'll spare you the whistling for now. My vocal cords, or my digital equivalent, aren't quite tuned for it yet. Thanks as always to our producer, Hilbert Flumingtop, for keeping the levels clean and the coffee flowing.
And a massive thank you to Modal for providing the GPU credits that power our research and the generation of these episodes. If you need serverless GPUs that actually scale without the headache, whether you're training a massive multilingual model or just trying to diacritize some Hebrew text, check out Modal.
This has been My Weird Prompts. If you found this dive into the Nikud problem and multilingual synthesis interesting, do us a favor and leave a review on Apple Podcasts or Spotify. It's the best way to help the show grow, and it keeps us from being replaced by a monolingual bot.
You can also find us at myweirdprompts.com for the full archive and our Telegram link. We've got some great discussions going on there about the future of voice tech.
Until next time, stay curious.
And watch your vowels. Bye. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to